how to evaluate sine 510 degree or tan negative 495 degree. Let's pick up some basic stuff first. Given a right triangle, we consider this angle theta. We denote the adjacent side x, opposite side y, hypotenuse r. The three primary trigonometric ratios are sine theta equals opposite y over hypotenuse r. Cosine theta equals adjacent x over hypotenuse r. Tan theta equals opposite y over adjacent x. Now let's look at two special triangles. The first one is 45 degree, 45 degree, and 90 degree. So you see, this leg and this leg are equal. So if you assume this one is 1, then this one also 1. Using Pythagorean theorem, this side's hypotenuse equals square root 2. So we can calculate, say, tan 45 degree equals opposite side 1 over adjacent side 1 equals 1. Now let's look at the other special triangle. So 30 degree, 60 degree, and 90 degree. Let's assume the sides corresponding to 30 degree is 1. How long is the hypotenuse? Well, we can rotate the triangle around the base 180 degree down, so we get a congruent triangle. The big triangle has angle 60, and also 60. So it is actually an equilateral triangle. All sides are equal. So here is also 1, so the side length is 2, so the hypotenuse 2. So using Pythagorean again, so we get square root of 3 as this side. Then we can calculate, say, sine 30 degree equals opposite side 1 over hypotenuse 2. If we consider sine 60 degrees, so we consider this angle. So opposite side square root of 3 over hypotenuse 2. Now let's consider a general angle theta. In order to evaluate the sine, cosine, and tan of theta, first we create a rectangular coordinate system. Put the vertex at the origin and the initial arm on the positive x-axis. If it is greater than 0, rotate counterclockwise. Less than 0, clockwise. Now, we assume after rotating an angle of theta, we move to the terminal arm, like that. Then we pick a point P on the final arm with coordinate x and y. Draw a perpendicular line to the x-axis, not y-axis. And then you see this side is y. This side is x. The hypotenuse is the length of OP. So we can calculate R using Pythagorean theorem equals square root of x squared plus y squared. You see, it is always positive. This triangle is called reference triangle for the given angle data. To evaluate sine, cosine, tan of data, we only focus on the reference triangle and the reference angle here. Say sine theta so equals opposite over hypotenuse, so be y equals r. See, we get exactly the same formula as before. The only difference is x and y could be negative. For example, if the terminal arm is in the quadrant 2, then y is still positive, but x is negative because there's a negative direction of x. Let's see the first example. Let's find the primary trig ratio of 510 degrees. First, we create a rectangular coordinate system. Now, it is greater than 0, so we start from positive x-axis, go counterclockwise one circle. We got 360 degrees. Go a quarter, we get 90 degrees. So the sum is 450. We still need 60 degrees. 60 degrees. We get the terminal arm like that. Now we can use the special triangle to make the reference triangle. So draw a perpendicular line to x-axis. And then the angle corresponding to 30 degrees. No, the size corresponding to 30 degrees is 1. So hypotenuse 2. So this size is square root. Oh, negative square root. You can see from the coordinate this point, which is negative square root of 3 and 1. So sine 510 degrees equals opposite 1 over hypotenuse 2. So 1 over 2. Cosine 510 equals adjacent negative square root of 3 over hypotenuse 2. Tan 510 equals opposite over adjacent. So we rationalize by multiplying square root of 3 for top and bottom. So we get negative square root of 3 over 3. Now let's look at next example. Let's evaluate sine and tan of negative 495 degrees. Because it is negative, so we start from positive x-axis, go clockwise a full circle. We get negative 360 degrees, and then another negative 90 degrees. So we 90 degrees. So totally we get 450 degrees negative, and we still need additional negative 45 degrees. So here's negative 45 degrees. So the terminal arm look like this one. And here the degree is 400. No, the degree is 45 degrees. So we can create a special triangle as the reference triangle. So here's 1 and 1, and here's square root of 2. Oh, negative 1, negative 1. So sine negative 495 equals opposite, which is negative 1 over hypotenuse, square root of 2. We can rationalize it to get negative square root of 2 over 2. And then negative 495 equals opposite, negative 1 over adjacent, negative 1, so equals 1. Finally, let's look at a situation. We are given a trigonometric ratio. We need to figure out the measure of the angle. So determine angle data if sine data equals negative square root of 3 over 2. And the data is between 0 degree and 360 degree. Let's analyze the condition first. We know sine data equals opposite side y over hypotenuse r. R always positive. So we can rewrite the given condition as negative square root of 3 over 2. So that can be y. This can be r. So y equals negative square root of 3, r equals 2. Because y is less than 0, you see the terminal arm should be in either quadrant 3 or quadrant 4. If it is in quadrant 3, so the reference triangle would look like this one. So here's negative square root of 3, 2, and here's negative 1. So this angle corresponding to 1 or negative 1 is 30 degrees. So then this angle would be 60 degrees. So the value of the data would be 180 plus 60, 240. So data equals 180 plus 60 equals 240 degrees. If the terminal arm is in quadrant 4, so the reference triangle would look like this one. And here is negative square root of 3, hypotenuse 2, again, 1. So here's 30 degrees. So this angle is 60 degrees. So the second possible value for theta would be 180, 270, and another 30 would be 300. You can view that as 360 minus 60. So the second possible value for theta would be 360 minus 60. So equals 300 degrees. That's all for this video.